This is an update in my continuing coverage of the mysterious star KIC 8462852, or Tabby star, for December 27, 2016. For the full backstory, I suggest checking out my other videos on this channel, starting with my first update video from April of this year, and my subsequent updates on this star. At this stage, the star is being monitored every night for the expected deep dimming events first observed by the Kepler spacecraft, and while there have been a few false alarms, Tabby star has remained stable in brightness since the observations began earlier this year, and while it's overwhelmingly likely that we're seeing a natural phenomenon, the alien megastructure hypothesis still has not been discounted. But the natural explanations that are emerging are improving in quality, and we seem to be moving closer to a consensus on what's going on here. But there is dissent. More on that in a minute. But which natural phenomenon is causing it? Several new theories and papers have emerged that may provide an answer. According to a recent paper by Jason Wright of Pennsylvania State University, these theories fall into four general categories. Category number 1 are explanations that lie within our own solar system. Category 2 are explanations that lie in the interstellar medium between us and Boyajian star. Category 3 are explanations that lie in orbit around the star, and Category 4 are explanations that involve the star itself. Category 1. The solar system. One idea is that there is a small, dense cloud of material in the outer solar system orbiting the Sun and passing by, blocking the light from Tabby star. While a reasonable idea on its face, this stands out as odd because we have never seen an analog of this cloud of material passing in front of any other star in the millions of observations we've made of the galaxy. Because of that, we have no real reason other than conjecture to suspect that such a cloud might be lurking out there. A second possibility is that there is a Kuiper belt object passing near the line of sight of the star that happens to be outgassing material, such as Enceladus does with water or even Io with its volcanoes. In other words, something spewing material into space. This would seem unlikely. You would need a bunch of conditions to be just right for a geologically active world to exist in the Kuiper belt. It would also need to be doing it in a way that's obscuring KIC 8462852. That's a tall order, but as Pluto recently showed us, bodies in the outer solar system can be quite active, and weird stuff does happen in our solar system, so this remains a maybe. A third possibility that hasn't been well fleshed out is a slow collision of comets in the Oort cloud releasing the material. If that's the case, it would probably be obscuring more than just Tabby star, so it's not a great solution. But all possibilities involving our solar system face two serious hurdles. Boyajian star lies well outside the ecliptic plane where the vast majority of matter in the solar system is congregating. While it's not impossible to have material outside the ecliptic, it's definitely there, it does disqualify most material. The further you are outside of the ecliptic, the less stuff there is to block light. The second problem is that there is some evidence, albeit weak, of potential periodicity in the material that was causing the dips in brightness that Kepler observed. In other words, we may have seen it pass by multiple times during Kepler's run. This is to say that there are indicators that the material is in orbit of Boyajian star, but it's really weak evidence. More observation is needed to confirm this. Think of it as hints of being in orbit rather than proof. Category 2. Material in the interstellar medium. The possibility of periodicity also affects any solutions in this category. If confirmed, it would eliminate any possibilities here. However, as it stands, it's still possible that some sort of material is passing in deep space between us and KIC 8462852. The nature of this material is debated. It could be dust or gas, or could be linked to any number of astronomical phenomena. One theory even proposed that the material is located in the accretion disk of a black hole. However, there are problems with all theories in this category for one simple reason. If it is a cloud of interstellar dust, it's a very strange one of a type we've never seen before. We've never seen one create the kinds of dips Kepler observed. It's not impossible, of course, but it is unlikely. Unfortunately, with all the explanations on the table for Tabby star, they all seem unlikely. The only consensus is that whatever this is, it's a very rare event, and that's what makes pinning it down so difficult. Category 3. Material in orbit around Tabby star. If periodicity is confirmed, this becomes the most likely set of solutions. The problem here is that all of them are really unlikely given what we've observed, and because of that, the potential for alien megastructures being the culprit remains on the table. But as with anything in astronomy, the last explanation you want to jump to is alien activity. While it's true that we really don't know how common aliens are, the Fermi paradox makes it safe to assume that aliens are very rare, or we would have seen them by now. It's also important to remember that we know absolutely nothing about alien megastructures because we've never seen one of those either. Trying to figure out what sorts of structures a civilization more advanced than our own would build is purely conjectural. We can theorize and speculate, but all we can really define with any certainty is that the megastructures can't defy the laws of physics. Because of all the uncertainty, megastructures end up being a wide-open explanation that can fit almost any strange phenomenon we observe in the universe. That's why we have to be very cautious when discussing that possibility. It's possible, but not a very good explanation for KIC 8462852. The natural explanations in this category advanced so far range from disintegrating comets to smashed planets. I've covered these in my previous updates in depth, so check out those for the backstory. But needless to say, none of the explanations are very good. All of them in this class have fundamental problems based on what we've observed. Category 4, KIC 8462852 itself. There's been a few explanations so far that pin the origin of the dips on the star itself, but until now they haven't been very solid. Star spots and dim areas of the star haven't really held up to scrutiny as far as the data we have goes. But a new paper suggests something more solid. It presents that Tabby star is undergoing an internal phase shift that's messing with the light that it emits. A group of mathematicians and scientists at the University of Illinois have been conducting a study and have authored a paper. They looked at how the dips in brightness mathematically relate to each other. This is not unusual. Patterns can appear in data, and you can study that. Sometimes significant patterns appear. Known as avalanche statistics, it can shed light on how and when natural phenomena occur. Importantly, it reveals information about phase transitions. Think of it as the snaps you hear in a stick as you bend it just before it breaks. The scientists suggest that the small dips in the Kepler light curve are related to the larger dips in such a way that they are linked. This is super important because it's the first real blow to the megastructure explanation. If the smaller dips are related to the huge dips, then the constraints placed on the alien megastructure theory shrink in a major way. At that point, it would appear that the star is to blame and that we've caught it in a very rare but very weird situation where stellar flares and internal conditions of the star are just so that its brightness is being affected in a strange but entirely natural way. Their model seems to be consistent with what's been observed. Only time will tell, however, if this theory holds up. But that's not the only paper that's come out recently. German mathematician Edward Heindel recently proposed that a specific type of alien activity would be consistent with what we see at Boyajian's star. Known as stellar lifting, this conceptual technology would allow a civilization to mine the resources of their star for raw materials. This may sound like science fiction, but in reality, we can think of relatively straightforward theoretical ways to lift material from a star and cool it for use using mirrors, localized heating, and magnetic fields. Heindel's theory is noteworthy in that it mathematically explains a very strange feature located in the light curve that has so far not been particularly explainable using natural means. This feature is unusually smooth, and while not impossible, comets and dust clouds would have a hard time creating it. But then again, just about everything we know about KIC 8462852 tells us that whatever we're seeing, it's incredibly rare and unusual. So there you have it. Observations of the star are ongoing, but the mystery of Boyajian's star is not yet solved. My transcript for this video can be found at my blog, The Event Horizon, link in the description below. You can also find links there to the scientific papers I referenced in this video for people that want to dig in deeper regarding this story, as well as regular posts about technology, interesting articles I find, and just science and technology stuff in general. Thanks for listening. I am science fiction author and futurist John Michael Gautier, currently with a new book coming out in a matter of weeks. It's called Supermind, and I'm happy to finally unveil the cover art by noted space artist John Kaufman. Link to his website in the description below, and be sure to check out my other books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.